So thanks everyone for coming out to build and coming to this session. My name is Sean Henry. This is Jill Bender. We're program managers on the App Fundamentals team in Windows. So we deal with a lot of stuff around the app model and how apps run across Windows devices. And we're here today to talk about Project Roam, driving user engagement with connected apps and devices. So to start, what do we mean by driving user engagement? As a developer, this is something that you have to be very concerned about with your apps. I mean, you want people using your apps. People spend a lot of time on computers, and watching screens every day. We know that, in the US, people spend over 7 hours per day looking at screens. And that 60% of people use more than 2 devices per day, 3 or more, be those, computers or televisions, or phones, or tablets, or whatever. People are using a lot of different devices. And kind of interestingly, what we also found is that 42% of people, and this is growing every year, start an activity on one device and then finish it on another. So throughout the course of the day, they start doing something on their phone and they finish it on their desktop, or they start watching something on their laptop and then they want to watch it on their TV. So people are kind of making their experiences transition or span across devices. And as an app developer, you want to be where your users are. Your apps need to span devices and platforms. They need to work everywhere. They need to work on tablets and desktops and phones and everything. And of course, this. You see that the top apps in the store, the Facebooks and the Twitters and so on, they make sure their apps are available everywhere that their users are. And you see this, with us as well, with Cortana. We try and make Cortana available everywhere, and also have it, have these experiences. And you saw some of these in the keynote, where Cortana, starts an experience on your phone and moves to your desktop or moves across devices. So what we've done with Project Roam is we sort of took this to heart and sort of took a collection of features and brought them all together under one roof. With our goal being to enable users and developers to connect and manage all of their devices, either proximally or through the cloud, all the devices that they use every day, have them sort of be connected and reachable via apps. And what we do is we expose to the developer the user's device graph, and allow the developer to sort of select which devices they want to talk to, pivot across devices and platforms and services. And what we're hoping this does is enables you as an app developer to build these really rich experiences that are, we say human-centric, in that they span across devices, they're tied to the task that the user wants to do. And I want to put this quote up here quickly from Bill Buxton. How many of you know who Bill Buxton is? Some of you, yeah. So he's a Microsoft UX researcher, and we were kind of putting this stuff together late in the year. We were talking with him, and this is a quote that he's published before. And what he's really talking about here is like this frustration that a lot of people have today of when they add devices to their network, when they buy new devices, their life gets more complex, and it should be getting easier. And that's really what we want to do. We want to make users' lives easier every time they get new devices. So how are we doing this? I mentioned that we took like a collection of existing features and sort of started tying together and improved them. And a lot of the stuff I'm going to talk about today is built on top of SmartGlass. So how many of you guys know what SmartGlass is? You familiar with it? A lot of you, yeah. So SmartGlass was this really cool technology for Xbox that allowed you to have these sort of companion app experiences between your phone or PC and the Xbox. One that we were just using the other day, there's these dance, you can picture me dancing, but there are these like dance games, and you can sort of control them with your phone. Or you can have these experiences like where you're watching something like Game of Thrones or whatever on HBO, and you can see a map on your laptop or on your tablet of where you are, where the scene is taking place. And of course, this worked cross-platform on Windows, iOS, and Android, and that's something we really took to heart. I mean, we recognize that people use devices across all sorts of different platforms. We want to make sure that as much as we can, everything works across all the devices that users actually have. And what we did is we took the SmartGlass technology and we we added the WinRT layer for contracts and services, these things like Launch URI, and I'll talk about this a little bit later, and app services. And we layered this on top and built a UWP layer on top of Smart Glass. So this enabled us to have sort of APIs that you're familiar with if you're doing UWP development and kind of extend them across devices. So that's enough about our mission statement. You guys came here to learn how to code some new stuff. So there's 3 things we're going to talk about here. One is getting users to your app, and we'll show you how to add show you a new feature called App URI handlers, which allow you to have users hit a web link, like an HTTP link, and go to your app instead of the browser. We're going to show you new APIs that allow your app to discover the user's devices, so all the devices within their graph, both through local networks and Bluetooth, and also through the cloud. And finally, once you have those connections to those devices, we have some APIs that allow you to build these experiences and communicate across devices, launch apps, communicate with apps, so you can build these kind of rich experiences that cross devices. So first off, handling web links. So in a lot, I feel this for all apps, but certainly in a lot of cases, mobile apps are better than the mobile web. And you're all familiar with this experience where you get a link in a mail, an email, or something like that, and you hit it and you want to go to the app, but instead you end up going to the browser. And this is not always the best experience for your user, especially if you've invested a lot of time in really building a rich app experience that's tailored to the device the user's on. They can be frustrated. So what we've done is we've created a new API called App URI handlers, which allows you to enable your app to be seamlessly launched when users hit HTTP links for your experience. Of course, this will increase your app launches. You won't get that kind of redirection. Some of you are doing this today, trying to get this kind of experience by redirecting to a website and then back to an app, and you have kind of the browser come up for a little bit. But if the app isn't on the system, also we'll gracefully fall back to that web experience. So the user always gets a good experience, and they're happy. So let's do a quick demo of that. So I'll move over here to the projector. And I have 2 Windows phones here. They both have emails from Jill. She has a cool article she wants me to check out. And the one on the right here is not enabled with App URI handlers, and the one on the left is. So we'll see what happens when I hit these links. You can see on the left, I get taken right to the MSN News app. Sorry, on the left, I get taken to the MSN News app. And on the right, I got taken to the website. And in the MSN News app, I get this really nice app experience. So it's as simple as that. There's not really that much to it. And I think let's just talk about quickly what was actually happening under the covers. So what the MSN News app did is they registered for an App URI handler in their manifest, and they also put a JSON file up on their website to tell us that the app and the website were linked. When the user tapped on that link, like I did in the mail, the OS inspects that link, and then instead of going to the web, it activates the MS News app with a protocol activation, and the user gets the native app experience. So let's take a look at that in code. Jill, if you want to show us the code.
Sure. Thanks, Sean. So like Sean mentioned, when you enable App URI handlers, you want to have both a website and an app experience that are mirrored experience. And in this scenario, I am a developer that is very passionate about marine biology. So clearly, I want everyone to know facts about narwhals. And so I've built this app experience, but because I want this content to reach my users everywhere, I've also built a website. And users are getting really excited about this content. They love it, so they're sharing it. And similar to Sean's scenario, here we have an email with links to this website. So right now, the problem is when you click on this link, you're taken to the browser. When you have this native app experience installed, and in this case, one of the cool native features that we have is that all the content is cached locally, so you don't have to be connected to the internet to make this work. The way that some of you are probably solving this problem today is with custom schemes. And you can see that we have a custom scheme link here. But the problem with custom schemes is if your app is not installed, then you get launched into the store. And the user wants to get to your content as fast as possible with a seamless experience. So let's see in code how we're solving this with app URI handlers. So first you want to go into your app manifest, and this is you declaring that your app has an association with a website. So this is the app side of the declaration. And you say, I have an extension category windows.app_URI_handler. And then in this file, you want to list all of the hosts that you would like to associate with. So for every domain for these links that you would like your app to be launched for, you would list them here. And that's it. And you can see it's pretty similar to the custom scheme registration that we have here. So if that looks familiar to you, that's great. Now, the second part of this is to have your website declare that they know of this app. So this is how you solidify the association between your app and your website. So the system is going to go to your web server root and look for this Microsoft App URI Handlers JSON file, named with the dashes in between here. So with this file on your root, you can list your package family name here. And if you don't know where to find that, it's in the package app manifest designer in the packaging section. And this is the unique identifier for your application. And this is your website saying that I'm aware of this application and we're associated. And then the system says, that's great, you're verified. So with this code, your app will be launched when users click on links to your domain. You can also customize these paths here so that you have a seamless experience. Now, once your app is actually launched, you'll get launched with an onActivated event, and it's actually a protocol activation. So you're going to check to see if the activation kind is a protocol. And in the event args, you're going to get the URI that the user had clicked to get you here. So this is where you have a chance to take the user directly where they need to go instead of the web. So we're going to break apart this URI here into a switch statement. You check the path, and in this case, we have several pages like the classification of narwhals, their diet, anatomy. So the user in this case, let's say they click the classification page. So we set the page type, and finally, we navigate them there. So let's see this in action. Let's see how this works. And the coolest part is that this will work from both Windows Classic applications and Universal Windows apps. Build is starting. Here we go.
It'll be worth the wait.
It'll be worth the wait,
It's going to be fantastic, guys.
Once this is enabled, it's pretty quick. So if you want to get users into your app, this is the way to do it. Oh, it's a live demo, folks. It's real. Let's try that one more time.
Just proves it's real.
Yeah.
There it goes.
OK, and we're off. OK, so remember we put our logic for activation and on activation. So I'm going to close this app. And we're going to see this working from Evernote. So here we have Evernote. We have the Windows Classic desktop version of Evernote, as well as Evernote Touch. So we'll click on this link here. And our app is launched, and it takes you directly to the content. So with just a little bit of code, you can get users to the content very seamlessly instead of taking them to the web.
Very cool. So a couple quick things to be aware of with app URI handlers. So just to finish this up, so when you sideload your application, we actually don't do that verification. So if you're in testing and development, or if you sideload an application, we don't do that kind of authentication with the website. Also, the user has control over these settings. So we're adding a new settings page called Apps for Websites, where the user can go in and manage these things and turn them on and off if they want to have a different experience for different apps. One other thing, and you saw this a little bit in Jill's code, but you can provide exclude paths, and you can provide wildcards in the JSON file that you put up on your website. And then, of course, this works for both Universal and Windows Classic applications. So that's it for App URI handlers. Let's move over to cross-device interaction. So what do we mean when we talk about cross-device interaction? Well, in our team, we kind of think there's kind of three different categories that we think of things. One is this kind of launch and message, where we extend the experience. So in this, these are just kind of conceptual to give you guys ideas of the things we're trying to enable. For your apps, you'll have some specific domain experiences. But when we think of launch and message, this is really a case where, for example, you have some app on one device, in this case here, a photo app, and you want to launch it on another device, but then have the experience kind of span devices. So you launch it, and now the app is actually running on both devices, and you send messages back and forth. So in this case, like in a photo app, you could be controlling which photo is being viewed, and have that experience then span onto another device. Another category is what we call companion experiences, and this is what we saw a lot of with like the smart glass stuff for Xbox and phone. So again, you can imagine you're watching American Idol or The Voice or whatever on your Xbox, and you can have an experience on your tablet that is a companion to that experience. So you could vote for your favorite singer or so on. And then finally, kind of the third category is this remote control experience, where you're using one device to control another. So imagine something like a 3D modeling application or whatever, and you can use the touch screen on your phone, for instance, to have sort of a richer experience or richer control. So kind of use the sensors and the input on one device to control another device. And I want to quickly show you here a live demo of this kind of thing, a little demo app that we wrote. So I'll go over to this machine here. So you can see on this side here, I'm projecting my phone through USB here. So this is my live phone here on the left-hand side. And I have this little app that we've written that's kind of like a podcast app, and it's got all the build sessions in it. So I can go through and I can select one of these, and it starts playing. And you guys can't really hear it. It's just playing on this phone right here. But you can see what I can do. What we've enabled in this app is the ability to have the experience span devices. So you see this little drop down that says devices available. And this has got the list of all of my devices. And I have this Surface Book over here that we can select. And then what happens is I've now launched the app over here, and it's launched behind the viewer. And if we can get the sound come up in the house a little bit, you can see that it's now playing through my laptop.
Really,
that's great. That's enough. So that was Andrew's session from yesterday, and you can see it's playing here, and I can still control it. If I go back to here, you can see that I can move around, and I can do forward and backward within it, and I can even completely finish the experience here on my phone, and it continues to work. This is actually, there's no sort of bits media streaming between the two devices. This is actually two apps talking to each other, and having an experience that spans devices. So let's talk about what's going on behind the scenes. So every time you associate one of your devices with a Microsoft account, we'll register that device with the cloud. And you can see your list of devices associated with your Microsoft account at any time by going to accounts.microsoft.com. And you'll see today, a list of all your devices. And they could be, obviously, Windows devices, but also, Android and iOS devices that you've signed into with your Microsoft account. And so now that we've registered all those devices in the cloud, we have this kind of list and this relationship in the cloud of all of the devices associated with your user. Another thing that we do with this platform is we discover devices proximally. So we have that information of whether the device is reachable nearby, within the same network or over Bluetooth, but also if the device is reachable through the cloud. And what this does is it allows us to give your application that list of devices and enable it to connect between other apps on other devices of the user that the user has. Again, either proximally or through the cloud. And finally, once you've made that connection, you can message between those devices and apps on those devices. So once again, over to Jill to take a look at this in code.
Thanks, Sean. So how many of you have actually tried to implement cross-device experiences before? Okay, well then you'll know that if you're going to try to implement these experiences today, it actually takes quite a bit of code to get everything working seamlessly. So I'm about to show you how, with just a few lines of code, we'll do a lot of the discovery and the background for you. So in order to get a list of these devices around you so that you can interact with them, first you need to request access. So this is similar to some of the other APIs that we have, like background location services. You need to ask the user first whether or not this is okay. So in their settings, users can in their privacy settings, set whether or not that they want to have their device discoverable. So first we request access, and if the user has given us access, then we're good to go to start discovering devices. The way that we discover devices is with the watcher pattern. And this can also be seen in like the accelerometer API. So this is fairly familiar. And what we do is we take remote system.createWatcher, and this will enable us to get notifications of when devices are being added or removed or updated on the system. That way we know who's coming and going so we can build these experiences. And finally, we start the watcher, and then we'll set a breakpoint here on the remote system added event so we can see what devices we get coming in. And this code right here will discover over Bluetooth, local networks, and over the cloud. So we should be getting all of those devices coming in. But we'll just get one device here, but you'll get notifications for every device that is added. So good, the application is launched, and pretty soon here we should see a device come up. Great. So here we have a remote system. This is a device that we've discovered, and we get a certain amount of information here. Here we have the display name, which we're using in our sample application to list all of the devices. You also get a unique identifier, just in case the display names are the same. And then you get this other interesting information, like the device kind and what kind of connection it's available on. So you can see if it's actually near you or if it's just available over the cloud. And you can actually filter on these devices, right, Sean?
Yeah, exactly. You can filter on whether the device is available proximally or the type of device, like a phone, a laptop, or an Xbox. There's a whole bunch of enumerations, and you do that in the remote watcher when you set it up.
Yeah, so let's actually see how that works. So here, if you want to filter on these, you only want to have a proximal connection because you have a very personalized setting for your application, then you can come in here and, come in here in the Create Watcher and add a filter in here. So here you can see we have the remote system kind filter. So if we wanted to filter for a specific type of device, but also like a discovery type. So that's one way that you can customize this application for your scenarios. So now that we have this list of devices, let's find out what we can do with them.
Right, exactly. Just having a list of devices isn't very useful. What you want to be able to do is have your experiences span devices. So we have something we call remote app handover. And again, we're trying to really build on top of APIs and experiences that you guys are familiar with. So how many are familiar with LaunchUI Async? This is a pretty common API that you probably all use to launch one app from another. Today on a single device, you can have your app launch another app by calling this API. One line of code, and you're launching another app via URI. And so what we did is we took this API and we made a remote version of it that, again, is very simple. It just takes a parameter of a remote system, and now you can launch apps on other devices. And that's what you saw in the demo. When I selected an item in that dropdown, we launched an app across device. So back over to you, Jill. Let's take a look at this in code.
Thanks. Okay, now we have devices. That's awesome. We can start building on these experiences. But first, we actually need to connect to them. So we take care of that for you in one line of code here with the remote system connection request. So you get a remote system from your watcher before, and you pass that into your remote system connection request. And then you're connected, and you can start doing interesting scenarios. So here, we're going to launch a URI. So we have a build browser, and then we have like a play state. So you can give some information in this URI to launch. And then, just like Launch URI Async, we provide you with remote launcher options. And we give you 2 remote launcher options right now, and that is a fallback URI, so that if the app is not available, you can still launch some content on the web. And then we also give you the option to launch a specific app. So once you set your launcher options, you can actually do your launch with remote launcher.launchURIAsync. And you pass in the connection request from above, along with the URI and your options. And then, just to double check to make sure everything worked, you can check your status. And if everything worked great, your app is already running on that other device, and you've got your app onto another experience for your user. But if something doesn't go well, if the connection is lost, the user leaves the room, and you were trying a proximal connection, you'll get remote system unavailable or a denied by remote system if your user's not signed in. And with that, you have your app running, and now we want to be able to message to it.
Right. So once again, we wanted to build on APIs that you were already familiar with. So for messaging between 2 applications across devices, we have an API called Remote App Services. And how many of you are familiar with app services, regular app services? This was something we introduced last year as part of Windows 10, and this allows store applications to provide services to other store applications. So for example, you have 2 applications, App A and App B. App B can actually open an app service. App A can open an app service connection to App B. And what this does is it actually activates a background task inside of App A. So App A doesn't even, inside of App B. App B doesn't even have to be running for App A to be able to talk to it and get information, have a connection between the 2 apps. And of course, App C can also talk to App B, and App B can be this application that's providing services to a lot of apps on your device. You can kind of build this web of apps as apps are talking to each other. And the API for this is fairly straightforward. All you need to do to consume an app service is to create an app service connection, provide an endpoint name, so this is the name of the service, and the package family names. This is the unique identifier that we talked about earlier for your application, so that we can find that endpoint. And then once you open that connection, it's as simple as creating a value set, which is a dictionary of key value pairs, and then populating that with data. And then the app B in this example will then get notified that there's data in that message that it can then go respond to and provide data back to the application. If you want to know more about app services in general, like a real deep dive on app services, there's a great session later today on app extensibility that you guys can go check out. But that's just kind of the surface of app services. But I think what we'll do now is we will show another demo in code of what that looks like for remote app services.
So if you're familiar with app services, great. If not, there's a session later today, so you can go and check those out. But we make a declaration in our manifest with category windows.appService, and this is you declaring your contract in your application. And then you can establish an app service connection. So like Sean said, here we have our connection.appService name, and it's called COM Sean Henry Audio Player. And we also have our package family name. And then we can make our connection request. And we'll get a status back from this. So we make a remote system connection request. And here you can see that we pass in our remote system that we get from the watcher. And then we can check that connection and make sure everything's going well. And similar to the launch scenario, if something goes wrong in this cross-device scenario, when you're working with lots of different devices, maybe you're trying to discover lots of them. You want to make sure that it's there on the other side. In this case, if something goes wrong, we tell an error to the user so that they can make sure everything's connected. And then, once you're connected, you can send any messages that you want. So the way this works with app services is it passes messages via value sets. And a value set is a serializable data type of key value pairs, and it's very similar to a dictionary. And here we're adding in the player state, since this is a podcast scenario. So we can make sure that we know what's playing and where it needs to be in the playhead state. So then we send our message with connection.sendMessageAsync, and we pass in our input, and then we wait for a response. And if all goes well, we have our app set up on the other side to respond with the result, and that way we can handle it also if something goes wrong, as you can see down here. And app services are a really powerful way to message between your applications because they're so customizable. You can define the interface between your applications and send pretty much anything that you want. So now with this very powerful messaging system, you can enable these cross-device scenarios easily.
Great, thanks, Jill. So a couple other quick notes about remote app services. And a lot of these apply to app services on the device, but they're just things that you should also be aware of, especially when you're going remote. So the service is activated on demand, so it's not always running on the target device. It only gets activated and only starts running when the source device calls into it, even cross-device. And the lifetime of that app is the length of the connection. And that connection can be terminated, of course, by the source, the consumer of that app service. If it disposes of the connection, it will terminate the app. Or if that app is suspended, it's kind of sponsoring the resources on the remote device, and that app service will be terminated. And finally, there may be situations where there's insufficient resources on the remote device to launch, and in that case, you'll get some of those status messages that Jill showed in her code, and those are great ways to figure out kind of what's going on and do the appropriate thing in your app. A couple other notes about remote app services, things that we've added to the existing app service APIs. So there's a isRemote property that we've added to the app service connection, so you can determine if you're being invoked remotely if you produce an app service. Also, if you're producing an app service, it's important to add this isRemote parameter into your manifest when you're declaring your app service. This tells us that this app service is reachable from remote applications. And then finally, the maximum size of that value set is 64 kilobytes. So if you do want to send more data across via that value set, you have to chunk it into smaller messages. So that was discover, launch, and message. And you can see, and you sort of tie that back to the demo we showed. That enables a lot of these really, really interesting scenarios for things like companion applications, launch and message, extending experiences across devices, and remote control experiences. You can discover the devices, start launching things on the remote device, and then have those apps talk to each other to build those kind of experiences. One other thing I want to talk about before we finish, I mentioned cross-platform a little bit, and it's very important for us to make sure these things work cross-platform. And all the APIs we showed now are sort of WinRT, UDP APIs, but we're also going to be releasing SDKs for iOS and Android to enable this. So I have here an Android device. Let's move over to the Elmo, and we'll have to do a little bit of quick switching here so you guys can see this. This code is a little bit hot off the press, so it may or may not work. So what we'll do, so here you can see we've discovered my my laptop over here, and we can do a launcher, and I'm just going to put in a URL here. Nope, we don't want to go to bibg.com. That'd be terrible. Or Biff, Bingf.
We can go there. Check it out.
All right, and so then we can switch over to this machine, and you can see here that we launched that. I swear that worked. It wasn't smoke and mirrors.
There was one tab before, and now there's two. I saw
you can come over and we can see that if you don't believe me. But it did actually work. I'm as surprised as you are. No, just kidding. We knew it would work. Let's go back over to the show here. So yeah, all those experiences that we just showed, we're committed to making those work on iOS and Android, and provide an SDK so you can build your native app experiences on iOS and Android as well. Because we recognize that not all users can be blessed to be on Windows 100% of the time. So let's finish up. So just to recap, we talked about 3 things today. Number 1, getting users to your app. So handling web links so that you can keep users in that world of apps and the expectation of staying in apps, and you can have really that great app experience for your users. Getting your app on other devices by discovering devices around you and then launching your app on those devices or launching other apps on those devices. And then once you have those apps up and running cross-device, a really simple and powerful communication mechanism between remote devices. So that's Project Roam. Check us out. We have a pod downstairs called Connected Devices Platform. So come talk to us. We'll have machines set up there, and there'll be someone there who can talk more about this. You can go check out this website. Right now, that's pointing to, I think, our build session this session once it comes up. But we'll have a lot more information there in the coming weeks. And our APIs will be available in an upcoming Insider SDK, so you guys will be able to take a look at that. But if you really want to take a look at them now, come on down to the pod. We have some machines that have the APIs on them. But yeah, expect that to come really soon. The iOS and Android SDK will be coming this summer as well.
Also, if you want to check out the App URI handlers, we also have a Quick Start Challenge.
Yeah, absolutely. Go check out that Quick Start Challenge. There's a couple other sessions kind of related to this. So a lot of the stuff that you saw, I mentioned Cortana earlier, and things that they're doing like around Cloud Action Center and extensibility. All of that stuff is actually getting built on top of our platform, or a lot of that stuff is getting built on top of our platform. So we are actually using a lot of this stuff in-house to build these experiences. So there's a couple other sessions that sort of talk about this a little bit. There's a notification futures session, I think right after this one, that talks about Cloud Action Center. And a bunch of things you can do there. There's a Cortana deep dive later. And then finally, I mentioned earlier, there's an app extensibility session later tonight. And if you want to know a lot more about app services and app extensions, you should definitely go and check that out. So that's it. If you guys have any questions, there's mics. I think there's 2 mics. So thanks for coming out. Question over there?
I have a question about the URLs that will launch the apps. I forget what they were called, sorry.
App URI handlers.
App URI handlers. Do you currently support, or do you have plans to support deferred links? So if they don't have it installed, they'll go to the store and then, after they install it, they'll get that link?
Yeah, so that experience is best through custom schemes, because that's the go and get this app experience, because you know that there's an app there. But one of the features of App URI handlers is that it has that graceful fallback to the web. So if it is a store link, like if it's actually a link to the store, that's one scenario that may be enabled for that. But that is definitely a great problem that we're facing. We want to make sure users get to that content no matter what.
Any more questions? Can't really see that well. Maybe over here, is there one?
I had a question about the side-loaded apps. So it sounds like in the anniversary update, you can just side-load apps. There's no restriction, but you won't do the URL validation in that case. Is that?
Yeah, that's intentional.
Okay.
So in the case where, let's say you have a separate web team and app team, when you're testing this feature out just to see if you can get it enabled, then you can just test it out without having to worry about having the JSON file up. There is a command line tool, which we'll publish documentation on how to use that you can verify your own file with the actual verification system that we're going to be using. So you can test that out on your end, and then once you get everything published to the web, then it should just be working.
Okay, maybe it's the wrong form, but from what I understood, side-loaded apps would side-loading app is different from installing a signed trusted root app. Those ones will still be validated, right? So you can get an app through the Windows Store, or you can install yourself from and sign your app.
Got it.
Trusted.
Yes. So if you install yourself, that they will be validated, which is different than installing from the store.
Perfect.
Yeah.
Thank you.
Yeah, I have also questions to the App URI handlers. When I, for example, declare in a manifest that I link my app to google.com, for example, and then the user wants to go to the website and then the app opens. Is it somehow possible that I can still open the website in the browser, for example?
Yes, so users have the choice. On the first activation, users will have the choice of what they would like to register for, similar to the way that default apps work today for custom schemes. So users get the choice there, but also you as the app developer will be able to launch into the browser.
Okay, thanks.
Yeah.
Any other questions? Okay, thanks.
Hi,
Oh,
I have
go ahead.
an additional question.
Yep.
Regarding the remote devices discovery, I understood that there's currently only one option to connect our devices through cloud. Is there an option to connect to devices in a local network or?
Well, yeah, so we'll actually give you both types of connections. So we will, we use the cloud as a way of mapping to from the user's account to the devices that they have associated with that account. But if the devices are visible proximally, we'll absolutely open that connection proximally. So be it on the same network or the same Wi-Fi network or even over Bluetooth. And you can see that parameter. When you get those devices discovered, there's a property on there that tells you whether that connection is proximal or through the cloud. And then you can specify the connection type that you want to make.
Okay.
One more question.
Can the device watcher detect devices of other users?
No.
No.
No, it's only users associated with your Microsoft account. Yep. Great, I think that's it. Thanks, everyone.
All right, thank you.